It's about Krill. We have a logo for it. Did you notice? Thank you for having me, first of all. My name is Alex Band. I work at Untitled Labs. We are a small research and development organization based in Amsterdam. It's the 14 of us. It's actually quite a small organization, mainly consisting of like 8 developers and 2 researchers. And we've been doing this since 1999, and in fact, I think next week, we're celebrating our 20th anniversary. So we've been around for a while. What we do is make free open source software that you may know from the authoritative DNS server NSD or the recursive resolver Unbound. So we do lots of other DNS stuff too. So we really love DNS. But the thing is, we always thought we make tools and we do research for core internet infrastructure. And that really includes BGP as well. So we sat at the lunch table and we were like, you know, what do we do? Can we do anything in terms of BGP to make like a software package that is on par and comparable to what we're doing with NSD and Unbound? And I said, why don't we do something with RPKI? Because after all, we have like 10+ years experience in that area. Because me and my colleague Tim, we used to work at the RIPE NCC, and we made this. We made the hosted RPKI interface for the RIPE NCC. And we started that like 10 years ago. And 2 years ago, we thought, you know, let's do another project, let's start a new adventure. And that's how we ended up at Untitled Labs. So I said, why don't we do something in this area? Because within RPKI, as Carlos explained, there's a lot of moving parts, and we thought that there were a couple of missing elements to the puzzle. We thought, let's make a certification authority for delegated RPKI. So the ability to run RPKI on your own systems, to generate a public and private key pair on your own systems and have it signed by the parent certificate authority. So that's what we thought was needed. Because routing security is like a really hot topic right now. You see RPKI coming back in the news, you see root hijacking coming back in the news. There's just a lot happening in that area. Lots of people are hijacking, lots of problems arise from it. And the adoption of RPKI, we really think that that can help in that area. So the 5 regional internet registries, as Carlos explained, offer a hosted service where basically you log into their web-based portals, you click a button where you say, can I please have a certificate? And then this certificate lives on the system of the RER. And then if you want to create a ROA to authorize your routes, you have to log into the web-based interface and do some clicking and then publish those changes, and then they are published in the repository of the RER. But then if you have a little bit of a bigger setup or a more complicated setup, or you would like more automation, then clicking around in a web interface, especially when you have a routing problem, is not a lot of fun. You want to have a little bit more control, and you want to have this closer to your source and do this internally. And this is what delegated RPKI gives you. Because the design is basically like this. It was always designed as a distributed system. Exactly like Carlos explained, it is a chain of trust with signatures upon signatures upon signatures, where you have the 5 RERs as the 5 trust anchors, the national internet registry sitting below that, and then LARs and ISPs and members and customers sitting below that. This kind of fine-grained control is also not possible from all of the hosted interfaces. So if you want to delegate a part of your address space and the management of ROAs to a different business unit, or for example to a customer, that is all not possible within the hosted interfaces. So you become responsible for all of the management for yourself, but also for your other business units and your other customers. Also with regards to publication, where ROAs are published in the hosted interface, that is always within the RER repository. You have no control over that. For example, control over the update interval when ROAs are published. So it's important to keep in mind that within delegated RPKI, it basically consists of two elements. You have the certificate authority, so it signs and generates signed statements about routing intent, and then you have the publication of those ROAs and certificates to make that available to the world. Now, those aren't necessarily two things that you have to run on the same system, and not necessarily something that you all have to do yourself. There are two separate components, and that is important for what I'm going to explain to you after this. So that was the idea. I proposed this at the lunch table. I said, can we please make a certificate authority and publication server for delegated RPKI? And then basically, because we're a small not-for-profit, the first question that was asked was like, hang on, that's not what I meant. I got lost in my story. Anyway, I meant to talk a bit about how publication works, because this is what it currently looks like. So you have the repositories of all of the 5 RERs. Below that, you have repositories of different NIRs. And below that, you have like individual organizations who may publish something themselves. And currently, it looks like this, where NLNet Labs actually publishes ROAs themselves because we need to eat our own dog food and we like to try our own things. But most likely, you will want to publish with somebody who takes care of this for you. So somebody who, for example, has good infrastructure for it, or maybe a content delivery network sitting behind it to take care of all of the consequences of running something that is publicly facing to the internet. And then the last piece of the puzzle is that all of this data that is published in all of these different repositories is gathered by relying party software, by validators, and then cryptographically validated with the result being fed to the routers. Now, I don't know if Carlos mentioned this, but I think the most powerful part of the RPKI system as a whole is that it's an end-to-end system. So you can make an authoritative statement that you're sure is being created by the legitimate holder of the address space. You're sure that what is being published can be cryptographically validated, and ultimately, the resulting data can be fed into routers that support this. And there is support from like Cisco, Juniper, Nokia, but also, and Arista Supportix, for example, on the verge of being released, but also software solutions such as Bird and FiOS all have native support for RPKI data. You can feed the data right into your solution and set up filters based on it. So I think that that's a really important and powerful part about the software and the solution as a whole. So the result is this. When you run an RPKI certificate authority, you run it as a child of a regional internet registry, a national internet registry, or if you're like a delegated customer, you can even run it as a child of an LAR. You install and maintain the software yourself, you generate your own certificate, and then you have it signed by your parent. You can publish signed objects yourself, or you can have it done by a third party. And within the solution that is going to be presented today, you'll find that NIC.br will offer publication as a service. So you can generate ROAs, and NIC.br will take care of publishing them. And that's great. You're completely operationally independent from the parent, and you can offer like tight integration with your own system. So if you make a change in your BGP routing, you can completely automate having ROAs published that authorize those new route announcements. And another important thing, if you're like a larger operator who has address space in multiple regions, you can create ROAs as a single pool. So you can set up connections to all of the 5 RERs and basically create ROAs as if you would have a single system instead of clicking around in up to 5 web interfaces. Lastly, you're in control of the publication interval, and as said, you can delegate this to your customers if you want. So this entire solution, I wrote it all up in like a 20-page document, and then the question that was asked was like, that's great, Alex, but how are you going to get funding for this? We visit a couple of conferences, like the IETF, the RIPE meeting, NANOG, we go around. And then we talked to different people, and it actually turned out that there were several parties that said, we're willing to help you fund this, because this is a solution that we need. This is a solution that we want. And we're willing to help you support that. And one conversation that we had was with Federico, and he said, it's funny that our paths come together like this at this point in time, because we were planning to offer RPKI as a service to all of the Brazilian members. And if this is a solution that you're making, then that's great. We're willing to support you, help this open source solution. So there we have it. And this all happened about 1.5 years ago. And it was like 2 weeks ago that we were happy enough to make a release that we actually deemed production worthy. And the result of that is called Krill. It is a RPKI certification authority and publication server. So 2 components built into one software package. So what is it that Krill can do now? Well, we designed it as an event sourcing architecture, making sure that you can replay all historic events to come to the current state. We think that's very important to make sure that you have data integrity. It can operate under multiple parent CAs. So if you are a big telco and you have space in like the RIPE region, the ARIN region, in the LACNIC region, you can operate it as a single pool. It works downwards, so you can dedicate pieces of your address space downwards to your customers. It supports the creation of ROAS. It has a built-in publication server, but it also allows you to publish elsewhere if that is what you want. The package is functionally complete in the sense that everything that you would want to do with RPKI is available. So setting it up under multiple parents, creation of ROAS, taking care of publication, it can do all of that. But the solution that we delivered, which is being implemented by NIC.br, is really tailored to like the command line, having an API, talk to it, so it easily integrates with their portal. But to make it usable for a regular operator like yourself, we have a lot more coming up to basically ease the onboarding process and to make the software better to use and more intuitive to use, because it may seem a little bit daunting at this very moment. So the first thing that we have planned is a web-based user interface that we have named Lagosta. We thought, since we're all doing crustaceans as our theme, and we programmed the whole thing in Rust, which has like a crab as its logo, we were fully on board with the whole crustacean theme. We decided that we wanted this to be an optional package. So we made like a Node.js thing, and if you're like, I don't want all of that because I will integrate this with my own systems, I just want to talk to the API, I don't want the user interface, then that is an optional component that you have. The other thing, and we actually think that is really powerful, we've noticed that with the hosted interfaces that we've designed as well, is that for the creation of ROAS, you would have to figure out exactly what to create in order to make all of your BGP announcements valid. And that may not always give you a lot of confidence, because you sit there and you created all of these AS and prefix combinations, and then when you want to publish them, you go, is this going to have the right effect on my BGP announcements? Didn't I overlook something? Am I going to accidentally make something invalid? You don't want to have that feeling. So giving you a preview of what the result is going to be when you publish your ROAS, what the effect is going to be before you put it out there, is something that we really, really want to build in. And that is also coming within the web interface. The other thing that we want to do is make sure that you have good packaging. So we already have a Docker container for it. And we also want to do packaging for like popular Unix distributions. The last thing is monitoring that we absolutely want to have. For example, something for Prometheus, but this is also where we want to enter into a dialogue with you, that you tell us what it is that you need in order to monitor this properly and have like good integration with all of your systems. And then if you think that that is needed, something like failover support with multi-master, having a more secure setup where you, for example, store all of your cryptographic material within an HSM. Then, you know, you can let your mind wander a little bit on what else you think you might want to have. You could think about integration with IP address management solutions, or you could have so-called just-in-time authorizations. So if you change something in your Cisco or Juniper or whatever other router configuration, then that change is automatically picked up by your provisioning system, and it automatically takes care of publishing a new ROA in order to authorize it. Those are all things that could be built if there's an interest for it. Then we also thought about cloud marketplace offerings like the AWS Marketplace for the DigitalOcean Marketplace, where essentially with one click it can spin up a VM and install all of the required components to run RPKI yourself, so you don't have to go through the whole setup process. And lastly, you could think about solutions like Krill as a service. So, mind you, the place where we are at right now is essentially the starting point for deploying RPKI within Brazil and the wider community. And we're really looking at you to give us feedback on what it is that would make it the best possible package to tailor to cater to your needs. So I mentioned La Costa, and we have a web designer working on it like right now. And he said, you know, can I send you some screenshots so people get an idea of what it's going to look like? So I was like, sure. Here we go. So yes, something with orange and those kinds of colors. But it'll give you all of the information. I think this is the most important. It'll allow you to create ROAs within a web-based user interface. The thing is that we also want to allow you to do this as a package. So create multiple ROAs, preview what the result is going to be, and then publish them all in one go. This is really close. So you can expect this to be delivered within the next couple of days or weeks. Probably not over Christmas, but let's say the beginning of the new year. And then you go, wait a minute. Am I running my own certificate authority? This involves like crypto stuff, and isn't this really heavy? What kind of system do I need in order to run this? And then I need to have like maybe publication as well. What are we looking at here? Well, for the certificate authority itself, modest hardware is really fine for most use cases. Well, what are you really signing? You have like a certificate, and maybe you have like 10, maybe even 100 ROAs. It has to sign like 10 to 100 things. And there's a re-signing process that happens. And basically the re-signing happens every 24 hours. And in order to be on the safe side, what we've configured it to is to do a re-signing process every 16 hours. So every 16 hours, your ROAs are re-signed and published. And for the rest, it just sits there, doing absolutely nothing. So you would normally run this as a service, so you would keep it running continuously, but you know, theoretically you wouldn't even have to. You could even run this as a cron job every couple of hours to start it up, do the signing, get it out there, and you're done. And the publication server, like I said, that is offered by NIC.br as a service. So it's important that you keep your publication available at all times. Your ROAs need to be available because validators out there in the world gathering all of this RPKI data, they will hit your server on average like once every 10 minutes. Now, if you scale out RPKI deployment over a couple of years, then probably thousands of networks will all run relying party software and start gathering all of these ROAs. every couple of minutes. So that is something to take into account with regards to publication. And luckily, that problem for you is solved by NIC.br. Now, to give you a practical example, we took Krill into production ourselves 2 weeks ago, and after 4 days of running, I was like, okay, let me see what it's doing, what kind of load we have. We use DigitalOcean ourselves to spin up a VM. We took like the one to smallest that was available. But looking at these numbers, we could have chosen the smallest as well. Something with like 1 CPU, 2 gigs of RAM would have been fine. I bet this could run on a Raspberry Pi. So I think that's 21 megabytes of memory. And then we also serve it ourselves, so we also have Nginx sitting there. So it's really not a big deal. And then the other thing, and that's important to keep in mind, is once you start thinking about crypto, then people go like, oh yeah, is this like DNSSEC? That if I do it and I mess it up, that I make my entire zone unavailable? No, RPKI is not like that. RPKI is a positive statement on routing intent. So if you completely shut down your certificate authority and eventually all of your cryptographic material would expire, then the positive statement about your routing intent goes away. And the result will be as if you never used RPKI in the first place. The only danger, the only thing that you need to take care of is that once you start publishing ROAs, that you maintain them. That you make sure that they are updated and reflect your current BGP configuration. Because if you don't, if you're like, let me attend the tutorial tomorrow, then I set up some ROAs and I forget all about it. And then a year from now, when people start validating, and in the meantime you've changed your BGP configuration, but you forgot to update your ROAs, then everything might be invalid and you might be unreachable to some networks. And you go like, why did that happen? Oh, it was because I attended that tutorial a year ago. So it's really important that once you start creating ROAs, you maintain them. Otherwise, it's better to not do it at all. There you go. I'm ahead of my slides. The other thing is that you should really make RPKI part of your standard operations. You have to make sure that you set up monitoring, you set up alerting. If something turns invalid, you get a notification about it. It's really important that you do that. And lastly, you have to make sure that you train your first-line help desk. Now, where we live in Western Europe, we have a lot of organizations that have already deployed RPKI, have published ROAs, and are actively dropping invalids. And sometimes that will lead to reachability problems because of a misconfigured ROA. And then the other party will call your first-line help desk and say, hang on, I can no longer reach you. What is happening? Why are all of my packets being dropped? And then the first-line help desk may go down a rabbit hole thinking like, what could be the cause? What could be the cause? And if they have never heard about RPKI, and that is not part of their standard operations, it doesn't come back anywhere. So you might end up looking for a solution in places where it doesn't exist. And the common practice that we see is that basically people say, I'm willing to make an exception for you and allow your traffic for the next 24 hours to give you an opportunity to fix your ROAs. And after that, I am dropping the traffic again. So that is really important. Maintenance and making sure that you make it a standard part of your operations and making sure that your help desk is fully up to date. Now, when we started this, in 2011, we started offering RPKI as a service when Tim and I still worked at the RIPE NCC. And we were like, we've been around the block. And I started at the RIPE NCC as a trainer, doing DNSSEC training and IPv6 training, and I know what adoption can be like. So we were like, this is a brand new technology, these are brand new standards. At the time, it wasn't even an RFC yet. And we were like, this may take 10, 20, 25 years? We don't know how long this is going to take for it to gain like reasonable adoption. But it turns out that now it's 2019, and there's like a really, really vibrant community. And you are on the verge of becoming part of that community. And you're stepping into like a really healthy, vibrant ecosystem with lots of different tools and documentation and tutorials available, which gives you a great head start to do all of the things right in one go that all of us did wrong in 2011. So that's really nice. And I really hope that you seize this opportunity to do something positive for routing security with this technology. Because as far as relying party software goes, back in the time, there was only one package available. There was one Java-based solution that you could use to download ROAs, verify them, and then feed the result to your routers. But now there's like seven. And you can choose whatever you want. And they're all well maintained. And you can make whatever choice you want. So there's the Fort project. So NIC.br and LikeNIC collaborated to make a solution in C. It's actually a really nice validator. We make one ourselves as well, called Routinator 3000. That is our space-themed thing. That is another developer who needed to have his own branding with it. That's how these things go. We don't have a marketing department, so people get to choose their names themselves. There's Octo RPKI from Cloudflare, the RIPE-NTC validator, which has been around for the longest, I guess. And there's several others as well that you could try. Even one integrated within OpenBSD called RPKI Client. The other thing is that the Fort project really does a lot to support routing security within Latin America. They have a lot of knowledge, they have a lot of webinars, trainings, and there's a lot of effort behind making that work. Also, the networking community within Western Europe, North America, Asia, they all collaborated on making rpki.readthedocs.io, which is like we try to have it be the canonical authoritative documentation on RPKI. We published this on Read the Docs because we thought that it was a great platform to do it. Everything is maintained within Git, so you can do a pull request and add new material or suggest edits, for example. But the beauty also is that it allows translations. So you could use a solution like Transifex or WebLate in order to provide a localized version of this documentation and have it published in the same place. There's, for example, also a public mailing list. We set it up initially for discussion around our own tools, but it actually turned out to be like a really vibrant community with people discussing operational experiences with regards to RPKI. So if you would subscribe there, you immediately get 200 people who can help you out, get started with this technology. And lastly, if that is like something that is really required by your organization, we offer commercial support for NSD and Unbound, and we'll be doing the same for Krill and Routinator as well. So if you need a well-supported solution, it is actually available from the start. And that's it. That's all I wanted to talk to you about. There's lots of links there, so if you want to know more about Krill and Routinator, you can visit our website at nl.labs.nl/rpki. All of the material is available on GitHub, and both Krill and Routinator have their own Twitter accounts, which you could follow as well. Another thing that I could recommend is that you follow the RPKI hashtag. There's lots of information coming by, lots of details on new networks that are dropping invalids or are dealing with traffic in certain ways. That's all I wanted to talk to you about. Are there any questions?
Hello, my name is Douglas. I have a very simple question. Why Krill? Why the name is Krill?
Aha, no, I'm going to defer that question to the developer of the software who is sitting right next to you. This is, and he's going to hate me for it. He'll hate me even more if I say that. No, I'm not going to say it. There you go. This is Tim, everybody. He made Krill.
We had too many discussions about which name to choose. You know, I wanted to call it like the Automatron or something like that. But we figured maybe, you know, let's not mix up the themes between the validation software and the CA. But it is a bit of a nod to the Rust programming language, which is very crustacean-oriented. And also, it's to do with filter feeding. So big filter feeders eat this stuff. And, you know, that seemed appropriate for DGP. So.
There we go.
Oh, well, I have an extra question as we are talking to Elna Net Labs. Can we do unbound better than nominal?
Excuse me, could you repeat the question?
Can we do unbound works better or have a better performance than nominal today?
I'm not sure. Because I know only CZ.NIC, who make not resolver, they publish like performance statistics, and I don't think the nominum software is in there. So I'm not sure how fast it is, and I'm not willing to go there.
Okay, it's just a provocation. Thank you.
It's Akamai software actually now. It's Akamai software now.
Yeah,
actually.
exactly. Yeah.
Hi, Thiago here. Just a question regarding the coding that you choose. There's Rust. What are the advantages of that, or what are the benefits that you saw using Rust?
Can I also defer that question to Tim? Yeah,
please.
Absolutely.
Well, I personally like it a lot. It has quite a steep learning curve to get into, but I believe it's a modern systems language that, well, what it says on what it promises is that it provides, let's say, modern language abstractions and concepts, but the compiler basically takes all of that away, so you don't get a performance penalty while running it. So, yeah, I guess it has to be kind of your style of coding that you like it or not. Especially, one of the main advantages of it is that it, the way it deals with things in memory. So values are owned and you can borrow them, but you cannot really keep them. So lots of issues that people find with memory leaks, well, the compiler really helps you there. So you can still keep stuff around for too long and create issues, but generally speaking, a whole class of issues is taken away from you. The price is that you really have to learn how to work with the model. So the first couple of months, if you start doing this, you probably get shouted at a lot by the compiler until, you know, it clicks.
But like classically, we're a C shop, and we really thought to ourselves, if you would start a brand new project in 2019 and you would have complete freedom what programming language to choose. So we really evaluated Rust and Go and several others, and we really thought that Rust was the closest to what we naturally use within the organization, and gives you lots of advantages over C while not having an impact on performance, for example. Anything else?
Yes, there is a remote question from someone, I don't know who, but he will know. Where is my stickers?
Oh, stickers, yes. I have a bag full of stickers. So, yeah, I could do several things. I could put them in front here, or you could find me over there and come and get some. And tomorrow at the tutorial, we'll have lots of stickers as well. Excellent.
Alex, thank you very much.